Jace, good evening, Jace. It's been long ago since we saw each other. How you doing, friend? How is life? Let me just test sending a message from VS Code. You're doing well. Nice. Okay, by the way, now I can see the chat in VS Code, so that's great. Editor layout. 2 rows. No, I don't want, wait, view, editor layout. 2 columns, right? So I'm gonna, So I'm gonna open chat over there. Nice. Cool, cool. Smadi, friend. Good evening. Good to see you, man. How is life? Ah, shit. Why did I do that? How do we... Let's keybind that. 2 columns. Yeah, that's... Come on. I've been very good, Jace. I've been very good. I haven't streamed, I haven't streamed much myself, but very good. Doing handover. I see, man. I see. Yeah, I've been at work and with my wife and kid and stuff like that, and I'm here a little bit with you guys now for a while. So let's kind of set up the stuff and get started with let's find some nice music, and then we yeah, then we go and no, I'm not going to be doing any new projects, Jace. This stream is always going to be about Programmer Network, but now we're doing Kubernetes and stuff. So now we're doing Kubernetes, and that's pretty much it. But I'm not going to be building most likely new things. This stream is always going to be more or less about Programmer Network, right? All right. So let's just test some stuff before we get started today. Today we're going to be setting up the load balancer, bare metal load balancer. All right, that's all great. So our Raspberry Pis are still up. And let's go over here and let's go to 192. Let's go to our Longhorn. Everything's still fine here. So that's great. That's super. So yeah, so today we should attempt and set up the load balancer. Actually, before we continue, so K3S, my DevOps team today at work, they told me about K3S. So actually, we're gonna start using this tool today. They're using it at Dream Data where I work, and it's super nice, super nice. So we're gonna actually install this. Let me actually just what the fuck is this? Let's just do this Kubernetes, right? Ravaz, good evening, buddy. Good to see you again. Thank you for coming, man. Appreciate that. Let me just, so this is the repository we're going to be working with, or we're going to be working on. So let's install K3S, right? Linux, I don't have Windows, Mac OS, Linux, very strange. I don't have brew installed right here. Oh, I do. Wow, okay, that's nice. Well, let's install brew. Let's install K3S. And then I'm going to show you, this is a super nice tool. For sure, Smatty. I mean, that is always ideal, right? It's always ideal that somebody who's using technology is, so absolutely. That's the beauty of experience, right? One thing is watching a random video, and another thing is talking to people who use these things daily, right? Okay, great. And then today we're going to be doing load balancers. So we're going to be doing what was it? Bare Meta LB, right? So today we're gonna set up this bad boy, and we need to stop some of the services we installed and stuff like that. So yeah. Actually, maybe I can open the chat, this bad boy, and what if can we like smack it? Let me actually try something with the streaming layout here. So if I zoom out a bit, let me know guys if it's too small. And then can I actually come here and split down? I can, right? That's nice. Okay, so I split this down. So here I can see your chat, and then we can have a Copilot chat over there, right? Can we? Yeah, exactly. So, and then I can move it here. Nice. So now I have basically a Copilot here, and I also have you guys. And the only thing that this extension sucks is that this input is kind of white, but yeah, it's fine. All right, so we have K3S. So let me show you this tool. So this is a super awesome tool, basically think about it almost as a graphical user interface tool, but it's a tool that actually gives you insight fully into your cluster. So you can see over here that if you take a look at this, here we have some things we can do with this. So for example, you can see attach help logs. So if I choose my Postgres and press L, I'm gonna get my Postgres logs over here, right? And then of course I can go back but if I go L, I have some other options. Give me logs past minute, copy some stuff, toggle full screen, blah blah. So this is a very, very nice tool, right? So you can see we can kind of get into, and if we go all the way back here, we see some pods that we have. I can press 0, and then we go to all of the things we have in our cluster. So these are all of the services we have. And then I can do describe, so I can go to any of them. So for example, I can go to, let's search for something. So we have a bunch of Longhorn Postgres. I can do and get some insight. So it's very, very nice. I actually prefer this over any graphical user interface tool. This is like having something installed, but right. I don't know how to pronounce your name, but good evening. Good evening. So that's the tool. So we're gonna use that. Cool. Kirk's lolgod. Okay. We do want to memorize them. We do want to memorize them still. I think it's imperative that we memorize them. But it's good to have this as a preparation for when we are actually very comfortable, right? Because you can see again here, this gives you an absolute overview into anything really, right? So from logs, blah, blah, blah. And again, as I said, if I go into certain things, we can pretty much do anything here, right? So we can start from all of the services we have, namespaces, blah, 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 and then go down into whatever we want, right? So Longhorn Manager, blah. So when we actually have some pods in here and we have some API running and blah, 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 then it's going to be useful because we'll be able to read the logs here. So for example, if I have Go API, Node.js API, whatever, we can come here and read the logs very nicely, right? And do various other things like, hey, show me, some details about this pod. So for example, if we go to down to Postgres, to this cluster we can have the logs, but we can go down and let me read the question. Just want to say that I discovered your stream and I think it's very friendly. Thank you, man. I want to ask a question. I'm 21 and I want to start programming. I was thinking that wasting another 3 years just to get a degree might not be good. Do you think they can get this field without a degree these days? I mean, I don't have a degree. I've been in this industry for 20 years. I studied, but by the time I was studying, I was already almost an expert in certain field, right? So I'm 36 now, almost. So you don't have to have a degree, but the times when I was getting into this industry, which was around 2007, was very different because the industry lacked a lot of people. And of course, it still lacks people, but it's a little bit different landscape today than it was before, right? So so it's definitely harder to get in today than it was, let's say 5, 10, 15, 20 years ago, right? So you don't have to have a degree, and in fact, degree means very little right now. Of course, this response is very, it can be very inaccurate depending where you live, right? Some regions require the diploma or whatever more than others, and it certainly helps if you're very much entry level, right? But once you get yourself into industry, get a first job, you get experience that nobody ever has asked me about my university, and I've been team lead, tech lead, you know, and I held nearly all possible positions except CTO so far. So your experience speaks for you, but unfortunately, when you don't have any, then anything helps, right? So it would be wrong to tell you don't study, but that also it would be also wrong to tell you that university is going to do much. I think university is very good to learn how to think and how to meet people and to make colleagues. The university is very good for various other reasons than learning to program. If you want to learn to program, that's not why you go to university. You go to because of various other reasons. Man, this fucking white theme is killing my eyes. All right, so let's see now, right? Yeah, I mean, again, yeah, diploma is really only needed or useful if you're a junior, right? If you can get some experience and some work and something, again, hiring is a very simple process. You go in front of somebody and you have to convince them that you know and that you're worth the money that you're asking for, or the money that they are offering, right? So there's really, that transaction is incredibly simple. There is really no hidden agendas there, right? So you go in front of someone and you have to tell them, why should I give you a job and not other 50 people that applied, right? So now you need to evaluate, do you have something to offer, and are they willing to give you that, what you're asking for, right? So when you're not in a good place, when you don't have so many things to offer, then of course any incremental, any small things help, including university, because the employer can say, okay, well, he managed to finish some school, so he's probably capable of starting and finishing something, right? So it's not that somebody cares about your diploma because of your knowledge. It's more of a, okay, they went through the process successfully, right? But do you have to have it? Absolutely not. Playlist link, yes. My pleasure. The concept section will give you, okay. So let's open our robot, right, again, and start there. But before we do that, yeah. So let's say cube control kubectl get svc a. So we have some services, and one of the ones that I created was the node port, is this one, right? So basically this one enabled me to expose my my Postgres cluster through the node port. So that's why if we go to our VS Code over here, right, we can actually we're connected to the database, right? So we can access it because of that. So now we want to really replace the we want to replace this node port, this basically ingress or whatever, with the metal load balancer, bare metal basically. So we probably want to destroy this one, so it's not exposing stuff. So the name is Longhorn frontend. That's a bit weird. Is that really the thing? No, this is the one. This is the one that I care about. So this is the one, yeah. So this is a namespace PostgreSDB, and the name is this, right? So we need to say, if I remember, cube control remove, right? A service, right? Or we can say SVC, I guess. Then we give it a name, and then we give it a namespace, which is PostgreSDB, right? Or delete. Yeah, I'm forcing myself to write these manually so I memorize. Yeah, there we go, right? So we delete that. And that's really the only thing that we need to delete, right? If we get the deployment, so cube control get deployment, and then a namespace would be PostgreSDB, I guess. Or let's see, get pods. So let's get all the pods. So we don't really have anything, right? So let's see, get so these are all of the namespaces we have. We have this namespace apps, right? So let's say cube cuttle get deployments and this. No resources found in my apps namespace. Just wanna, okay. Let's see what, let's say cube control get SVC namespace my apps. Okay, there's none. Okay, so I guess we can nuke this. Let's nuke this. So let's say what is this namespace? So let's say cube control delete ns, right? And then my apps. So let's just not have any useless things running, right? So let's make sure we clean up. And now, if we do cube cuttle get svc services, so we don't really have anything that we manually created here. The only thing we really have is traffic, which I believe currently might be our load balancer. I'm not sure. I think it is. So that's what we're gonna have to learn in a second. All right, so let's go back and forth with our robot, right? All right, I want to set up metal LB with my K3S cluster. Currently, I have set up my cluster with native PG operator, and also with Longhorn. Now I would like to add the load balancer so I can well, load balance and also expose my cluster. All right, let's see, setting up metal load balancer. It's called metal because it's bare metal, right? We're setting up the cluster, this cluster here, right? So this cluster is in our own office here. Setting up metal LB with a K3S cluster is a great idea for exposing services that would typically require a cloud-based load balancer. By doing so, you can create a load balanced service even in local or bare metal environments. Below are the steps to configure metal LB with your K3S. Since you mentioned you already have K3S set up with Postgres operator via native PG operator and Longhorn, let's proceed. Oh shit, okay. So this we will have to do. You have a range of IP addresses available that metal load balancer can use to assign to services. These addresses should be in your network range, but not managed by domain host client protocol, dynamic host client protocol, to avoid IP conflicts. So we'll need to do that, right? So let's go over here. Let's say to do create a subnet or whatever for metal LB. So we're gonna do that. Here okay, so basically we're gonna define the address pool there, which means we'll need to go to our MikroTik router as well, and we'll need to do some magic there, right? MikroTik Winbox, right? So we'll need to do that on our router, right? So just to remind ourselves, we'll need to see the router board 3011. So we need to configure that guy. So somewhere under the IP addresses, right? Or whatever, or the address list. So we're gonna create an address list most likely here. Or we're gonna do something like, or maybe we're gonna set it up on the DHCP level. We'll need to see, right? But either way, we'll need to create a network of some sort. But it could be also that we're just gonna provide a range over here. Have the interface list Ethernet. So we'll see in a moment, right? I don't know yet. Okay, so let me just move this thing to okay, let's so when it comes to the IP range, is there something that I should do on my MikroTik router to create an IP range that has to match the IP range inside of this, inside of the YAML file, right? Yeah, configuring your MikroTik router is properly to make sure that IP ranges specified in metal configuration works smoothly within your network. Exactly. Reserve IP range on your MikroTik. You need to ensure that IP range defined for metal LB doesn't overlap with your router's DHCP pool or other static devices in your network. This step is important to avoid IP conflicts where both metal LB and the DHCP server could attempt to assign the same IP address. So basically, it's almost as if metal LB has its own implementation of DHCP, and then it's kind of issuing the IPs, right? Verify your DHCP range and identify a free range. If you're using Winbox on the web, log in your MikroTik router, find your DHCP leases to find your current DHCP pool. Let's say it's this. Identify an unused IP range. The example suggests that DHCP is responsible for IPs from 50 to avoid conflicts. You need to use an IP range. Yeah. So this is fun. So we're gonna have to do some networking now. Give me 1 second. Nice. Okay, cool. So we have 2 steps, right? So we need to set this guy up, and then we need to do some network configuration, which is great. And we will do that for sure. Okay. So if we take a look at basically, if we take a look at this amazing AI and what it's telling us, it's basically what I assumed, right? So you can see under DHCP server we have networks and leases. That's if you remember, some of you who watched the first couple of streams of these series that we're doing now. If we take a look at DHCP, right, and then we go leases, right? If you remember, this is where we have actually assigned static IPs to our Raspberry Pi. So you can see these are 4 Raspberry Pis that we're working with, these fellas here, right? And this is where we assign static IPs to them. So we don't need to do it on a host machine level per Raspberry Pi. We just set that to our router. Hey, you know, log these fellas. Log these MAC addresses to these IPs. That's fundamentally how DHCP is going to do it, right? So now if we take a look at the robot here, as I call it, it's telling us, hey, how about you add a static IP range to be excluded from DHCP, right? So we go to the networks. Here you can manage static ranges and DHCP excluded ranges, right? So that's what we probably should do. So we should go to the networks and then create a network of IP ranges that then DHCP is simply gonna ignore, right? So if we go to the networks here, so this is the default one, right? And that's essentially what this guy assumed as well. You can see it was to some degree, right? So that's what we kind of gonna do, right? So we're gonna take some, so we can see if we actually go if we go to our current leases, we can kind of see that the range that's taken right now. So we have, if we actually try to sort them, so we have from 240 to 50. So we could basically select something before these, right? And create a network of that, right? So on your MikroTik interface, navigate to IP networks. Here you can manage static ranges and DHCP excluded ranges. For this, set the IP range outside of your DHCP pool and exclude it from DHCP assignment. For example, to exclude 192, 168, 210, blah, 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 pull from a network, the overall network, blah, blah. Yeah, so if we create a new network, right? And we'll need to give it some name. So the gateway is going to be the same, the DNS, the server is going to be the same, it's just the range that is going to be different, right? So let's see what is it telling us to do. Where's the DHCP range? I forgot, it's been many years since. Where's the actual DHCP range? I don't see DNS server, DHCP options, what is this? Yeah, I don't actually remember the UI, but where's the DHCP range? This is not the range, this is the gateway, the addresses. I wonder if we can, give me a second. Wait, so let me just do one thing to help myself. So let's take a snippet of this. Let's take that there. Are you suggesting that we create a new network subnet in there? Okay, so reserve a static IP for metal. From the screenshot, we can see that the entire subnet is being used exactly. DHCP is likely giving out addresses from DHCP pool somewhere in the range, possibly 20 to 200, depending on what configured in the pool. Decide a range for MetalDB. You want to decide on a small static IP range that allows, well, used by MetalDB. Ideally, pick IPs outside of your dynamic DHCP pool to avoid conflicts. For example, let's say you want to use the range. Okay. Okay, let's just go back and forth with it, just so we make sure we do it properly. So if we go under leases over here, right, and just provided a screenshot. All right, let's see. It appears that DHCP is currently assigning IPs from the 240 range, which is the block you were considering using for MetalDB. Based on this, to avoid IP conflicts between your DHCP and Metal, you need to free up a portion of the IP range and adjust your DHCP configuration so it no longer assigns these IP addresses. You'll need to modify DHCP pool so that the IP range you want to reserve for Metal is manually excluded for dynamic allocation. Yeah, but I don't want to do this, right? Because then I would need to reassign my Raspberry Pis. If the DHCP pool currently uses a large range, you'll want to reduce it so it excludes the range you want to dedicate for Metal LB. For example, reduce the DHCP pool where was this? This was under DHCP server releases, and then we have IP poll, right? Yeah, exactly. I'm starting to, yeah, here. So this is basically, this is my IP poll, right? So you can see that the default DHCP takes IPs anywhere from range 10 to almost to the up to the broadcast, right? So so I'll just give more context to the robot, right? Yeah, but okay, so this is almost kind of good, but this guy is wrong. Yes, but why are you suggesting an IP range that is already assigned to my Raspberry Pis and some other computers in the network? That would mean that I'd have to assign new static IPs to my Raspberry Pis in the cluster. Makes no sense. Makes no sense. It's better to pick an IP range. Exactly, like what the fuck are you doing, man? Review the current. Based on DHCP release screenshot, it looks like the devices in your network, like Raspberry Pi, are already using the IP range of that, yeah. You can simply choose another unused range that is outside of the dynamic DHCP. Yeah, so let's... Yes, I wonder, because I don't remember honestly, but I wonder if we should just reduce this range, right? Because we only really have, only thing we really need to do here is reduce the range of this DHCP, right? And then we can count that other IPs are not going to be touched. So for example, what I could do, I could just say issue from 100 to 254. We don't really need more, right? So let's ask the, yeah, so yeah, like just DHCP range to leave an excluded block, yeah. Right, something like that. Alternative, okay, yep, Okay, okay, what if I update my DHCP IP pool range from this to, I don't know, exactly, right? This means that these addresses between 10 and 99 will no longer be dynamically assigned, which is perfect if you like to reserve that range for specific devices and MetaLB. This good approach, it simplifies your setup since you now use a clearly defined block of low IP addresses, blah, blah. Yeah, exactly. So let's do that, right? So let's make sure that if we take a look at the leases that nothing is using that range, and it indeed isn't, right? So we can update the DHCP here to 8800. We can apply that. Hopefully my internet is not going to go to shit, especially now if I'm streaming. It shouldn't really. Okay, we're good. And now we can reserve stuff for the metal load balancer. And then basically we can reserve these bad boys, right? So this is what we've done. Did DHCP only exactly reserve, and now we can kind of get back to the metal LB. Cool, cool, cool. Okay, so basically let's just write a note here now to do. So we have this IP range for it, right? Cool. Okay, good. I had to do this a little bit cautiously because we really can't mess this part up. Okay, so now let's do this. Create metal LB namespace, but we can also take a look at their official documentation. So So let's actually learn a little theory about how this works. So let's go. Let's open up a new chat. That kind of sucks ass. Okay, explain metal LB to me as I'm 6 years old. No, but that's not. No, that's not what I. We know what a load balancer is. That's no. I don't really mean explaining what a load balancer is, but rather some ways of how metal LB has been built and things to consider. That's not very specific, am I? Right? Okay, at the core level, metal LB helps computers. Let's just zoom in a bit here. Okay. All right, so it says at the core level, metal LB helps computers in Kubernetes group handle network traffic so they can communicate with the outside world. When people want to access something like a website or a service running inside Kubernetes, metal LB provides a way for them to do that by assigning IP addresses to services. Metal LB was created because in some environments, especially on-premise, which is what we're doing, right? Which means computers in your own facility, there isn't a built-in load balancer like the cloud providers like AWS or GCP. Metal LB fills that gap. Types of models in Metal, a big decision. Metal LB works in two different modes, depending on how your network is set up. These are like two different ways to play with your toys. Layer 2 mode, direct connection. This is likely giving your toy cars IP addresses to your friends directly from your hand. Metal LB lets certain computers in Kubernetes just ask for a specific address and directly use it. We'll see what this means in practice, hopefully at 1.0 Pro. It's simple, it doesn't need a lot of setup. Con, it might not work well in big areas with many people, or in technical terms, might not scale properly with complex networks. BGP mode, using a map. If everyone wants to play with the same toy but they are far away, you need a guide, a map, to help them find the right one. Border Gateway Protocol helps your computers share information about how to properly send and receive network traffic, like following directions to the toy's location. So this basically one requires more underlying network infrastructure knowledge. When setting up Metal LB, it's important to know how your network is built. Here are some things. Are you running Kubernetes in the cloud or bare metal? If you're running in the cloud, you usually don't need Metal LB, of course. If you're running on-premise, bare metal is great because it gives you control over assigning IP addresses without needing extra fancy hardware or expensive tools. Do you have enough IP addresses? IP addresses are like tickets numbers that let people access your services. You need to make sure you have range of these addresses that Metal LB can use, or people might miss out. Do you need to handle BGP? Okay. All right, we'll see. I mean, we can't obviously conceptualize all of this now because we need to see this working in practice. So let's do that. But we understand that it has two modes, and one mode is easier to set up than the other. We know that a pool of IP addresses that we gave it now might or might not be sufficient. So basically, it only has really 89 IPs. Is that sufficient? Well, we'll see, right? I guess it depends how many services we have. So probably at one point it's going to need a lot more, maybe multiple subnets or whatever to work with. Okay, cool. So with that kind of project maturity, very important. MetalDB, yeah, I actually read this. It's already used in production, so yeah. I have no idea what that means, to be very honest with you, so that's fine. So if we actually go back here, the version that we have, so probably gonna follow this. So we're gonna create a namespace metal LB system, so that's fine. So let's get over here and let's create this namespace metal LB system that we know how to do. We're gonna do the apply, so we're gonna install their manifest, but we're gonna install it from their official docs because that's the latest version, right? So we're gonna do this. It's gonna probably do a lot of stuff. And then we're gonna verify that. We're gonna, oof. Some knees will be broken. Yanis. I don't know if it's Yanis or if it's Guga. It's colleagues from my work. It's probably Yanis. Sounds like Yanis. Okay. Yeah, so there are certain things now in this namespace, so it feels fine, I guess. I'm not sure. All right, and now we need to set up the IP range, right? So things we already discussed. Yeah, the only thing I'm unsure here is the version, API version beta. I'm not so sure about that, right? Yanis, I love you, man. Thank you for saying hi. Usage, for example. So yeah, okay. So no, it's fine. It's good. So this is essentially production service will go here. Public IPs are expensive, so we released just 4 of them. Ah, thank you, man. I'm glad that you like it. So I'm glad that you like it, my dude. So okay, so what we gotta do, right? If we take a look at the OpenAI, what's telling us, we need to create the config map, which I actually haven't yet learned about in Kubernetes. We'll need to learn that as we go. Or have I actually? I might have, I don't know. But we have the kind API address pool. Namespace is this, my IP pool. So yeah, we'll name this a little bit better. We will give it this. We know what we have done on our networking level, right? Because now our DHCP is issuing addresses from here to here, everything lower than 100 and up from 8810 to 99, like we said, basically is free for grabs for this thing. So let's grab this fellow over here and let's smack it here under examples, right? So we're gonna go to our exercises. Let's create a new folder here. Let's call it metal LB, metal load balancer. And I guess we can say, we can call it as the robot suggests. I guess the robot is way smarter than me. So okay, cool. So now, because we remember the IP range that we decided on our network to assign to it, it's a huge IP range. I don't think we actually need this much of IPs, but it's fine. What I'm actually gonna do now, let's drag this robot here. So let's highlight this and let's just say chat, because chat is already open. Let's just say explain each line in the selected file, right? Just so we're gonna use GitHub Copilot just to add comments here. I'm gonna actually do this on all of our configurations across the whole project because we still suck at this. So let's say add this as comments to each line of the opened YAML file, right? Just so as we keep opening these declarative files, we can actually always memorize what it does, right? So I'm gonna make it. I was referring to my currently opened file metal-lb config YAML. Jesus Christ, man. For fuck's sake, dude. Why are you lagging? All right. So let's just grab this piece and let's move this here. Actually, you know what? Maybe I should have just, can I somehow swap this over there? Yeah, I can. Nice. So maybe I'll just keep my chat there. And then we, yeah, so just you guys can actually see a little bit easier, right? So this is what we have now, and we can just insert, like, actually, no, it's fine. I'll just do this. Okay, so let's take a look at this. So defines the kind of resource, which is IP address pool. And I guess this kind relates to the actual metal load balancer. The namespace, and if you remember, we've created this namespace. So if I say cube control get ns, we should have metal LB system, right? So is that correct? Yes. The name of the IP address pool. So let's just call this I don't know, let's call it microtik address pool, just for fun, just so we're memorize. I specify API version defines the kind of resource, which is what does means in the context of metal LB. Okay, so basically, if you remember, the layer 2 advertisement is their second mode in which their algorithms operate, right? So they have two algorithms, right? The simpler one is this metal LB layer 2, basically networking layer. It's going to issue IPs and stuff. So if you read a little bit about it, Chica, my friend, good evening. Layer 2, in this mode, metal LB uses standard Ethernet frames to advertise the IP addresses to local network. This means that the IP addresses are advertised using ARP, address resolution protocol for IPv4, and NDP, neighbor discovery protocol, also very important. This mode is simple to set up and works well in smaller, flat networks where all nodes are on the same subnet. And that's basically, in our case, that's the case, because if we take a look at the networking layer over here, right, if we go to IP, DHCP server releases, we can see that our Raspberry Pis are in fact all in the same subnet, including my own computer from which I'm streaming right now. So that seems to be reasonable, at the very least. Explanation of this, yeah, so defines this kind of resource, namespace, the namespace, blah, blah. Okay, well, cool, right? Okay, so, but what I'm actually going to do is, I found somewhere the example, right? There was some example somewhere, full example, yeah. And this, let's be careful here. Let's read. Am I still searching? Yeah. As an example of how to use all of the metal load balancer options, consider an e-commerce site that runs a production environment and multiple developer sandboxes side by side. The production environment needs public IP addresses, but the sandboxes can use private IP space routed to the developer's office through a VPN. That would be a cool setup. Additionally, because the production IPs end up hard-coded in various places, DNS security scans for regulatory compliance, we want specific services to have specific addresses in production. On the other hand, sandboxes come and go as developers bring up and tear down environments, so we don't want to manage environments by hand. We translate these requirements into MetaLB. First, we define two address pools and set PGP attributes to control the visibility of each set of addresses. Okay. So this is the public IP range, I see. Yeah, but this is vastly superior to us. We don't really need this. So this would be almost as if we were building like our own managed solution of Kubernetes, and we were like exposing hundreds of different services, and each needed its own private IP, right? So we don't really need this. This is awesome to see, and it makes sense, and we might even do this, right? to some degree, but this is too complex for me to even comprehend fully right now. But fundamentally, you can see, because this is kind of true, right? IPs are getting public IPs is expensive, even if you're getting them from your ISP at your own home, right? So here, basically, yeah, they have 4 IPs, which are that is fine, right? But we don't need that. That is vastly superior setup to what we need. Okay, so we did this, and now we have to apply this config, right? So let's do that. So we're gonna go cd Kubernetes something, and then we're gonna say apply, and we're gonna go. It's not gonna be Postgres. Now it's gonna be, what is it called? Exercises metal lb metal config. So it says IP address pool metal lib MikroTik address pool. So we've created the address pool, right? And we've created, so actually if we use this tool that I've heard from my colleagues at work today, so K3S, so this is basically almost like a graphical interface for Kubernetes just in your terminal. We can actually, in fact, now go and just see all of these things. So if we actually search for, I think I was, can I search here? No. I think I was able to search today, but let's try to find this over here. So we have some services here. CSI, that's not it. Longhorn. So maybe at the bottom somewhere. Metal system. Yeah, here it is. So we have the namespace. So I don't know what these speakers are, but if we go inside of there, so we have some logs. If we go actually inside, but I want to see the pods, right? So where can I see the actual pods? Yeah, we'll see. I don't know yet. Okay, let's forget that for a second. Are you still developing? Yeah. I mean, I haven't streamed in a couple of months. I just came back to streaming. But yeah, Programmer Network is still that's still going to be after we finish the Kubernetes and we learn it. That for sure is still going to be the still going to be the thing that we're going to do for sure. Yeah. That's always going to be at a central point of this stream. What did I want to see? Yeah. So yeah, we can see that we do have some services created by MetalLB here. It is a cluster based, which is a little bit strange. So I'm not quite sure how this works. Thank you very much, man. Thank you. Thank you for coming by. I've been very good. Just, yeah, I haven't streamed in a long time because I just didn't feel like it. So I'm back for some time at least. Oh, okay. This is the trick, right? So create a deployment nginx, create 2 replicas of it, then expose the deployment nginx, right? So we create a deployment, we expose the deployment on the port 80, and then we say it's type load balancer. And then, I see. And then, oh, I see. Okay, I like this actually. So let's try that. So we're gonna create a deployment called nginx with image nginx. We're gonna say 2 replicas, right? I like this. This is cool. Cool. Right, and then we just expose that. And then if we get the list of services now, we should have one with load balancer. Nice, man. That is so cool, dude. So now if we actually access this in my network, bam, there's the nginx. Super cool. But what if I say 12? So this has been given the, okay. So this now has been given this IP by the load balancer, I suppose, right? Cool. Okay. So now basically, if I would do network address translation on my router, on my MikroTik router, right, and this fellow over here on the top, basically you guys will be able to access this thing immediately, right? Very nice. Okay. And then they're basically saying, hey, because if you remember, some of you, if you were here when I was doing that, if we take a look at, for example, Postgres examples we have in the service over here, so you can see now we've been using node port here, but this guy is telling us like, hey, Alex, you know what, man? Now you can actually expose this using load balancer. And we're going to do that actually right away, because that's super cool, right? And then we're going to get a new IP. Man, this is pretty awesome. Give me a second. So we don't need the node port stuff. We're going to need the target port. We just really need the port here. So protocol TCP and stuff. So I suppose we could omit this, right? And then if we do the apply, so my Postgres service, and then we say SVC. Nice. So now we can basically connect to our, so if we go over here in my VS Code, we edit this bad boy, and we just say, hey, you know what? Oops, that's not what I wanted. So if we change the IP, it's going to fail because of the wrong port, because now it's the actual, so we're not, so it is the default 54321 Postgres port. Bam, there we go, we're connected. Who is we? I'm sorry, and hi. Who is we? Hello, we recommend using reverse proxy engine. Who is you in plural? Oh, fucking commercials, man. Whisper. All right, let's find something else. All right, so that is pretty awesome, man. That is pretty cool, actually. That is pretty cool. I have to tell you that. So now because we have now kind of we're making sure that our DHCP is not issuing IP ranges from that thing. We can now ensure that our MetaLLB. So we can see basically whenever we create a config like this. So I guess, yeah, I don't know. I need to wrap my head around like how would you now use this in general. But I guess we could create different IP ranges based on different services. And when would that be necessary? It's unclear yet. But we can see that this in fact works, right? And we can see that the meta load balancer. So if we actually also use the Kubernetes plugin here in VS Code, if we actually go to the workloads, now if we go to configuration, config maps, now we have some stuff here, but that's not what I actually wanted. Where was the networking part? Network, yeah, here it is. Network, services. And then we have Nginx, right? Yeah. So if we take a look at that YAML file, that's of course generated behind the scenes. So yeah, I guess that is fine. I'm just kind of skimming through this to see if there's anything interesting in these generated things. Service account token, status, we don't actually care about it. Host IP 241, so this is the IP of my Raspberry Pi. This is the pod IP, basically internal to the cluster. Services. Yeah, so I guess that is fine. That is all fine for the most part. So fundamentally now at this point, We have persistent storage using Longhorn, which basically works like almost like RAID 1 if it was disk related. We have a native PG operator, and we have metal LB. So in simple words, this is literally almost the full setup we need. Now, of course, there's going to be other parts of this thing that we still now, the completely second part, going from the networking layer from here and creating a NAT and masquerade and all of that stuff, right? Setting up the firewall, Mangle, network address translation, right? Kind of getting this thing to the actual internet so people can actually access it from outside of my network. And that's a separate part entirely. And for that part, we're going to have to do a lot of stuff. Not on the router itself. I can do that in around 5 minutes now or less. It's more about issuing SSL certificates, creating a CNAME record in Cloudflare, and doing various other things, right? There's going to be a lot of stuff. Give me 2 seconds. All right, cool. Ah, shit, why did I do that? All right, so what is it? What is the next thing that we want to do, in fact? So we actually have that. There's a bunch of stuff we need to read here. So yeah, we'll actually clean this up. We gave up on the optimizing the fan speed of Raspberry Pis because we can't do that due to the nature of the fans we have. Yeah, so I think this is something we could do. I found this amazing blog that did a bunch of things that we want, especially this part, installing the cert manager, implementing FreeSSL. So yeah, having some cluster issue like this, and then setting this up with Cloudflare. And we'll also need to set up Nginx as well, yeah. All right, I don't know if I'm going to do that now, though. All right, what I would actually like to do now is a full-fledged... Okay, let's actually draw now. So we have pretty much everything that we need. The physical storage that we can provision. We have the load balancer that works. We have the database. We have Postgres using the operator, the PG native operator. So let's now create an exercise here. Let's call it full stack example, right? Something like that. And let's draw a diagram in here just so, let's call it full.diagram.io. .diagram. Draw IO, sorry. All right, so I'm gonna actually kill that. Gonna close that. So what I actually want to do is create a volume Okay, actually, let me think. So I guess if we take a look at our Longhorn here, so we have some volumes already. So we don't really need to provision that, but I think we should. So provision a PVC. Provision a database, native PG operator. Now, basically at this point, because right now, what I've done is, come on. Right now, if I do cube title get PVC, dash A, shit. Yeah, why am I not seeing them all? Kubectl get PVC. Why am I only seeing those? Network services. Yeah, so we have these, so why am I not seeing them here? Postgres cluster. That is weird. Okay. Let's get. Oh, actually, there's the wide thing, right? I forgot about that. Dash O wide. Yeah, but that's yielding a different result. That's so weird. Well, either way, we do have Postgres external load balancer. So yeah, we're exposing this. We're exposing our database now outside of the cluster, right? And probably we don't want to do that, right? We want to. So right now I'm purposely just because I wanted to connect from this computer to the database, and that's fine. We probably don't want to do that. We want this Postgres to be internal, and only the pods that need the database should connect to it. So in this example here, I suppose, because we'll really only want to expose the port 80 and 443, right? The SSL one. So and then eventually we're gonna have a deployment of some sort, right? And then we'll maybe need to provision also some sort of resource. So let's okay, so let's actually ask this guy here. Okay, and let's actually see, are we done with this? Additional IP range, ensure your IP range won't conflict with other devices. Method will be stateless, and it won't permanently keep the same IP when reassigning configuration. That's fine. Okay, so let's just tell to this guy. Okay, so now I have a working K3S cluster with metal, LB, Longhorn, and native PG operator. Let's generate a full example of provisioning a nodejs API that connects to the cluster IP Postgres, and create some persistent volume claim, something like that. I just want to know. Now we have all the components kind of, right? So now I need to think about this a bit, right? All right, great. Now that your K3S cluster is running with MetalB, Longhorn, and native Postgres operator, you're ready to provision a full application stack. Node.js API, persistent storage, load balancer, access to Node.js API service via MetalLB. Exactly, right? So we'd create a persistent volume claim, right? Something we want to allocate some space from some of our drives to this new application. Yes. Create a config map for the Node.js environmental variables. Yeah, so this is essentially just, dealing with envs. Create a deployment for the Node.js API with the PVC and config map. So yeah, here we're gonna basically allocate the RAM and I guess number of replicas exactly. Config map, just hey, where should I read the environmental variables from, and then the volume claim that we previously created with our Longhorn, right? So here we're saying, hey Longhorn, create a new persistent volume, and assign it to this specific deployment, right? So now we have the Node.js API deployment. Then expose the Node.js API using a load balancer. And yeah, that's lovely, man. That is so fucking cool, dude. I'm so happy after a few streams we got to this point. Because now fundamentally we can have a fully working, let's say, an API as part of our cluster that's running, multiple replicas and stuff. So next thing is going to be for us is going to taking a look at this thing called tilt, right? I just discovered this by researching like all of these things so far, and this is going to basically help us during development, right? So are your servers running locally in Kubernetes? Both. Tilt gives you smart rebuilds and live updates everywhere so that you can make progress. So the idea with this thing apparently is that developer experience. So when we're developing in Kubernetes, apparently things become easier in a sense of live updates, hot reloading, and stuff like that, right? So let's go. Has anyone tried tilt with Kubernetes? Kubernetes is up and running, rocking, but what's the easiest way to do local development in KS cluster with a few components? I feel like I got the hard part working first. Think we did that as well. Now left battled by the easy part. Feel free to laugh at me as I'm too. I've set up a cluster with kubeadm and deployed an app with few basic services to few physical worker nodes. That's what we did as well. It's working great, but how do you do local development without doing a full deploy? Suppose I want to test significant change. Do I need to build a fresh Docker image every time, push to my Docker repository, and then do a rollout? Yeah, very good questions. Right, super important, right? There's a number of tools developed exactly for this scenario. Tilt, that's what we just checked there. Let's skim a few others, right? Scaffold, Scaffold is a very popular one. This is super, actually I think at Dream Data, Patrick and my team uses this. For that only, and for that reason I might use it as well, because now I realize that this is what they use. Because then I can just learn this as well and have it benefit me at work. Develop and test K3S apps faster. Let's take a look at the popularity of these things, because that not always, popularity doesn't always mean good, but 3.4K stars. Scaffold, I would expect more, 15K. And you can see that I actually have this starred. So this is probably the thing we're going to use. Tell presence. Yeah, what the fuck is that? Yeah, I don't know what is this. I've never heard of this. So we're going to not give it any chance and then deploy and develop. No, it's fine. All right, I think Scaffold will be Scaffold for sure. So let's just smack that on top of our to-do here. Probably not today, but let's just say next stream. We're gonna do that, right? So we need something that's gonna help us do development, right? Okay, done. And let's just, yeah. So this is definitely the most popular thing. Container and Kubernetes development. Scaffold handles the workflow for building, pushing, and deploying your application. allowing you to focus on what matters the most, writing code. True. I'll just very quickly just skim through to familiarize myself to see the idea in my brain. Nice, man. That is super cool. That is super cool. I already see what's happening here. Google Cloud Storage, fuck that. We're not using any, so hopefully this works with a bare metal as well. So let's not, yeah, okay. But I'm interested into seeing this thing. Checkout scaffold, they use it for local development, great. I have a developer who is advocating to move our development out of KS and not even explore these various tools. He wants to create a script that would run all 9 of your Python services and the front end Node.js locally outside of. That's not a bad idea, honestly. I mean, you can just write a shell script that does this in 20 minutes. So this is not a terrible idea, in fact. I feel this would create a huge dependency issue, but I'm having a hard time showing the value of. That is a reasonable also solution. I don't care. Okay, if you're using Docker, my team uses tilt and it works great. We wrote a tilt file for our services and each developer runs a kind cluster locally. They set up kubeconfig variable and run tilt up. The tilt file contains logic to build the image and push to a registry plus update the cluster with new image. Well, okay. Yeah, so this is still in game then. So a lot of people are mentioning this. So let's just smack that as an alternative and then we'll evaluate once we get there. K3D, I don't know what that is. Oh shit, good. If you're running a little baby K3S cluster, which we are doing, crap, that's, oh wow, that's a nice find. K3D, what is that? K3D is a lightweight wrapper to run K3S Rancher Lab minimal Kubernetes distribution in Docker. Yes. 2 seconds ago, I was sure about something else. Nice. All right, so it seems this is going to be something for us. Makes it easy to create a single and multi-node K3 clusters in Docker for local development on Kubernetes. K3D is a community-driven project, but not official Rancher SUSE project. Let's give this bad boy a star. Let's actually disable this annoying plugin because it's making things. All right, cool. Well, this looks great. We'll probably try to set this up. That would be super cool. Okay, let's dev space. Scaffold. Okay, so wow, that's cool. Jesus Christ, man, there's so many of these things. All right, fuck that. So that's good. That's great. All right, cool. So yeah, so that's great. That's fine. That is okay. are these the actual pods? Nginx true running. Yeah. So this is indeed Nginx. And this is another pod. Yeah, so it's replicas, right? So 2 Nginx instances running. So if I would nuke these, is there a way to, in this K3S tool, I wonder is there a way to find the services and stuff? So let's go help. Yeah, okay, so let's see here. So what do we have? Sort, YAML, view, transfer. Is there like a search or something like that? So these are all resources, right? Yeah. And all of them are running. Yeah. We have, yeah, so we have these 2 namespaces. So I guess, so if I delete the namespaces, I wonder if it's going to nuke everything else. I'm not sure. And actually, I'm just going to do another thing. So if I go and SSH RP4 and then I do btop, htop, wait, so I do btop here, right? So our CPU is 35 degrees. Utilization is at 8%. What is running? We have Longhorn Manager, K3S Agent, Longhorn. All right, cool. Let's exit that. Okay, cool. So yeah, okay, good. Okay, going back to this then. Yeah, this is the full-fledged example that I wanted to do essentially, right? So this kind of does, now we can do the full end-to-end thing. So create a persistent volume, create a config map for our environmental variables, just the dummy shit. Create a deployment for the Node.js API. This is the image. And then we have the mount path. And I guess this mounts a local path on. And I need to see what this mounts to, right? A person's volume mounted at app data is used for storing data. Okay, never mind. All good. Expose the service. I get that. Cool. So let's say in theory that this is our app. So I think, yeah, we'll okay, let's compose this example. So I think first and foremost, we should probably copy this thing. We should go here, and yeah. Just leave this here for now. And then what are we gonna have? We're gonna have a PVC, right? So we'll just create these files as suggested. Weasel, my friend, good evening. No, I mean, yeah, I never know if I'm gonna stream, right? So not much you can do, man. Not much you can do. With me, it's never. You never know, right? So that's how it is. How are you doing? How's life? Yeah, this kind of sucks, man. Like, okay, so that's fine. So we have the PVC here. We'll review these things, right? We have the config map. So we'll just do this. I have a config map in there, right? Gonna grab this. I think actually I'll also, oops. Oh. That's not what I really wanted, right? Yeah, actually, that is probably correct. Okay, so let's actually give me 2 seconds. Weasel just no, that's not what I want. So we have the config map, right? So let's do this. So that's cool, right? Yeah. We're not going to apply anything yet. We have the deployment. I just want to kind of set these things up so I have a good overview. So we're going to have the deployment. So I just want to have a full-fledged example that works kind of end-to-end. I have set up the Metal LB Weasel as well. So development, Node.js API development, yes. Let's just do this. One or more containers resource. Okay, so let's see if we can use our copilot to fix this. But I understand that it's saying, hey man, you need to limit the memory and CPU and stuff like that. Exactly, right? So resource limits, CPU, memory required, blah, blah. Okay, got it. And then is there anything else that we still need to kind of get from this example? Then we need the service, right? Node.js API service, which is going to use. When you say, how did you copy like that? What do you mean? What did I do so I can give you a response? Because I'm not sure what you're referring to. Oh no, I mean I've just moved this MD file to the project, right? So I mean, oh yeah, but that's how ChatGPT and that's how they copy by default. You just need to click the copy, right? They always generate Markdown, right? They always generate Markdown. Snail, my friend, a long time no see. Good evening. I think these are all kind of things that we have to do, right? So yeah, so these are kind of this full-fledged kind of steps. I'm very good, man. Very good. I've been just doing other things. I just you know me. Yeah, I've been just focusing on fitness and family and just I'm not as I always say, I'm not a typical streamer, right? There's no guarantee that there's never a guarantee that I'm gonna stream, right? You get what I mean, right? So you know me, it's you never know. I might stream now for a month and then not show up for half a year, right? So it just I do it just the way that I feel, right? So yeah. Right now I'm working on Kubernetes. I think you have the link in the top. I haven't pushed a lot of things, but I'm working on Kubernetes, setting up the local cluster. So I'm setting up that physical server at home and doing a lot of really fun things and you could say complicated things as well. But yeah, it's a lot of fun. It's a lot of fun. We're setting up this cluster with 4 Raspberry Pis, MikroTik router, and 4 external drives. And yeah, it's yeah, maybe a little bit hard to digest for people who watch because there is a lot of things we've also done so far. But that's how it is. That's just how it is. Dude, that's great, man. I mean, of course you're gonna get there, man. Just put in the work, put that ass on the chair, right? And of course you're gonna get there. It's not rocket science, right? It just takes it's a process type of thing, right? There's a lot of these configurations, there's a lot of these things, but fundamentally it all makes sense, right? So the good thing with a software that's been written good, like Kubernetes, is that people who have built this are very clever. So none of these things is really like out of the ordinary, or it's hard in a sense that there's a lot of stuff, right? So it's not even hard. It's just a matter of build some server like this, and play with it, use it for production, expose it to the internet. Like, we're gonna hopefully host our programmer network on this. So we're gonna have a lot of excuses to maintain it, to break it, to secure it, and stuff like that, right? But you need to make, if you decide to do it, you need to find a use case for it, right? Because otherwise it's gonna be very difficult. I've been learning Kubernetes when it came out, literally, many years ago. But you play with it and blah blah blah, and then you simply don't touch it anymore, right? So that's the problem. I used to work as Cisco engineer in 2008 and 7, from 7 to 2009. And these are the things which are, of course, you don't forget the core of things, but a lot of these commands, specific, technology-specific commands, you forget over time. So you have to use it all the time. What are you using for an OS? I'm not sure what that means. If you mean which operating system I'm using all 3 operating systems. For my work, I use MacBook Pro, so I use Mac. All of this is running on Linux, all of these services, and I'm streaming from a Windows machine because it's the best for streaming. So I'm not sure if that was the question, because I don't know what you mean. What are you using for an OS? I use all operating systems depending on the problem, depending what I'm doing. Yeah, exactly. So, and now basically we could copy just this random simple app.js, right? Just to so yeah, but fundamentally, yeah, that's I'm very happy, very very happy. So we did a pretty awesome thing. We have so much more to learn, and let's not pretend that we know anything. We don't know anything yet. Just because the load balancer and all of these things work doesn't mean we know shit. We don't. But that is fine, right? We now have a fully working cluster, right? That we can also expose to the internet and stuff. And there's a lot more work. It's gonna take us, I don't know how many more streams to fully say, okay, now we feel comfortable with MetalLB and Longhorn and Postgre and PG operator, native operator, and all of these things. I use Nginx as load balancer. That's nice. I mean, we could have done that as well, right? So it's fine. We're gonna use Nginx for something anyway, most likely, probably for some sort of let's encrypt logic or whatever. But yeah. So this now works. That's super. So you can see we have 2 things exposed on the corresponding external IPs. So that is super awesome. Can we do things like this? No, I forgot, but I guess we can do okay, we have no pause there, but either way, so of course we will not be exposing our database outside of the cluster like this. This is just so we can test it from my VS Code, right? Because if we actually go there now, if we take a look at this, the tables that we have, the cars itself. So let's actually see, are we in fact still connected? Yeah, we are actually still connected. Okay, that's a little bit weird. So let's see what's happening. Cars. Okay, so there are the cars, right? Let's say limit 1. All right, cool. I thought that we had a query that we've created, but okay, let's try to create a query. Select all from, what is it, cars, right? Okay, great. Let's just say here, insert into cars, name, price, value, audio, whatever. So what do we have? Brand model year. Brand model year. So let's insert a few of them. Let's say where. Yeah. Okay, cool. So that is good. That is all great. We'll need to kill that. We'll need to stop that. Let me actually just once more try K3S. Just because I would like us to kind of get this a little bit better. So what it is that I'm looking at right now. So we are looking at the context, the cluster, and the user. So we see everything right now, I suppose, right? If I say this, no. Okay, so if I do this, oh, it's going to show the node on which this is running. So RP4, this is a Raspberry Pi 1. I can see the name. Okay, cool. If I say describe, it's going to show me the config. So this is a namespace called cube system, right? So this is pretty awesome, actually. We just need to get used to this. We need to use this a lot. So, and then we have a bunch of these services. So we have SVC load balancer nginx. We can see this with the acronym SVC LB. So service load balancer. If you take a look at this, so system node critical controller daemon. I have no idea what most of these things mean. Okay, here we have some networking. And that's cool. We have tolerations. I have no idea what that is. And then I guess, what do we have here? Some events, some logs or whatever. Okay, cool. Let's do the same here. So we can also say the logs. Is there any logs here? No. Pending. So I don't know why these things are pending. Then we can also do the same here. We can say describe D, right? So we can kind of get into, this is the my Postgres, this is a cluster configuration or something. And then we have the nginx stuff. So if we go into the one of the nginx things and we do logs, and then we actually go and hit that refresh, you just hit refresh a few times over here. Let's actually go and do like ping, you know, or curl. How can we but yeah, we can see actually curl coming in, right? You can see in the left, if you take a look at the logs, we can see that the logs are actually live. You can see, so that is pretty awesome. That's one awesome tool. We don't need to install any graphical user interface or whatever. We can kind of, so we can see the curl. There's really no browser. There's no user agent, right? Because this thing, we're getting this because it's parsing the user agent from the browser, right? So that is pretty cool, man, right? No, K3S, sorry. No, we are learning. We are learning, Weasel. There's a lot of stuff, so let's not pretend. Let's stay humble. I need to stay humble so I don't envision that I know something. I know nothing yet, so let's just keep it like that. It's gonna take some streams. It's gonna take some streams, but resubscribed for 18 months. Oh my God, Matty. I love you, man. Not because you subscribed. Thank you so much. It means more to me that it's you rather than the... but Matty is one of my first streamers. When I started streaming, I don't know, a year or two ago, he was one of the first viewers, and he's been around for so long, man. Good to see you. There are a few other guys that hopefully are going to come back, as I haven't streamed in like 3 months. But good to see you, buddy. Thank you so much, man. Thank you for coming. I appreciate that a lot. As you can see, we've been doing a little bit different content now, Maddie. We've been doing Kubernetes past week since I came back, and we're having a lot of fun. Hopefully, I'm going to record a course on all of these things once I internalize them. So I think, yeah, because if I go to my YouTube now, this is a bunch of random content, just us learning shit. But if we, like, there's a bunch of these videos. Actually, I should probably name this one to number 10, right? But I will record the course aggregating this into something digestible for most people. Let me just save this. So this is my 10th stream since I came back, basically. Dude, yes, let's go. Yeah, man, like family is everything, my dude. Family is everything. I'm very happy for you. Hopefully we're gonna have at one point another kid. We really hope, we really want that. So that's amazing, dude. That's badass. Super happy for you, man. There is nothing more important than family. And you will see when you get your kid, you come from work and stuff, and he or she hugs you and stuff like that. Man, there's no feeling that beats that ever. There's no feeling that beats that. So make sure that you're there for your better half, if I may say it that way. Nice, man. Nice, man. I got a drink in the name of that. I got a drink. I'm gonna have a little zip of something after I end the stream. That's super nice, man. That's super nice. Let's see if who was the other guy, man, that was always there with you, Matty? What was his name? You remember him? He hasn't came by in a long time. The British guy. I don't remember what was his name. Shit, what was his name? Crap, I don't remember. But there was another person with you always there. And by the way, just going back to this for a moment, right? So this is probably what Helm is for, right? Because you can see now when we kind of aggregate things in, when we kind of encapsulate it, when we put it almost as a component itself here, you can see that for each setup, you know, we need to do. I see. So you can see probably, I suppose this is where Helm probably comes in handy, right? Because now for every single thing we deploy, we always need to do the config mag, the deployment, the PVC, the service. Is the Helm? I'm not gonna start using Helm yet, but it's just I would like to know the what problem does it solve. So of course it's a package manager and it helps install stuff. Okay, let's actually now let's just ask the robot, right? Because like when we take a look at these, right? Okay, I think it's going to be a very rational question. I just want to know. I'm not going to do any change. I just want to know. All right. So now when I'm learning a bit of Kubernetes and as I'm getting the feeling of it, it seems that for any deployment, there's always a bunch of files that follow up. Exposing, networking, storage, PVC, deployment, etc. Is there the best pattern or something community accepted on how to deal with these things? Is there a standard tool that makes this a bit easier, or this is how it is supposed to be? Okay, so my suspicion is instantly there. Okay, let's see what it says. Okay, stop generating. You're absolutely right, Alex. You're always right. All right. I'm not going to say no to that. I know, but thank you. You shouldn't have said that. Always right and humble, as I always say. Working with Kubernetes often results in managing multiple YAML files for various components like deployments, services, PVCs, configurations, and more. While this approach gives you a lot of control over how your application behaves, it can quickly get overwhelming as the number of manifests grow. Yes, that's what we just spoke about. I like being right. Fortunately, the Kubernetes ecosystem has matured, and there are several patterns and tools available that are widely adopted by community to simplify managing Kubernetes resources. let's go through some common approaches and tools that can help streamline. Oh, man, I hate this word. Since I started using ChatGPT and OpenAI and other LLMs, this word streamline is everywhere, man. Whenever I see a post on LinkedIn and there's a word streamline, I'm like, yep, ChatGPT generated. Like, nobody has ever used this fucking word until AI came out, man. Go to LinkedIn and every second article is going to have a word streamline in it. Okay, Helm is one of the most popular tools in Kubernetes ecosystem. It allows you to bundle multiple Kubernetes resources into a Helm chart that represents a complete application. Helm provides a templating engine, enable you to define variables and reuse common elements across multiple manifests. Yeah, man, dude, 100%. I'm not judging people. I'm using ChatGPT more than anyone on this planet, probably. I use it for everything, for cooking, for Danish lessons, for everything. I mean, it's impressive. It's just like, come on, man. You know, find a different word. Single source of truth bundles all your resources into a single chart. Templating, use various variables for things like image versions, resource requests, config values. This drastically reduces redundancy. Reusability, Helm charts can be shared and reused by others. Versioning and release management, Helm provides an easy way to upgrade, rollback, and manage releases of your application. When you create a Helm chart, you'll have a well-organized structure. Like this. Node.js API, charts, templates, all of your YAML files, values, define default values for variable. I guess envs, I suppose, I'm not sure. And chart defines metadata for the chart. Yeah, so this, yeah, we'll see what that is. In templates, you would put all of your Kubernetes YAML configurations. You can template the values in the manifest. Yeah, I'm not gonna do this yet. I still suck way too much to start. So I do want to suffer. I want to suffer for a couple of weeks. I want to do things manually, and I want to get irritated. I want to get so irritated. It's like, fuck, man. I keep writing these things like in this and that way. You can see how already now, after just few streams, and even though I still suck at Kubernetes big time, clearly, it's still, it's already irritating me. Because, you know, from all of the experience these 2 decades, you know, you kind of start seeing like, shit, man, like, how am I gonna structure this? Like, you know, there has to be a way. So it's good that it's just naturally I asked this question, not out of my asshole, right? So that's great. It's good. I like that feeling. I like the feeling that I'm already kind of like, all right, man, is there a better way? And there is, which is great. All right, this I haven't heard about, to be honest. Customize IO. Helm, my guys at Dream Data where I work, they're using Helm for, I think, 2nd year now, so that's good. So I'll most likely use whatever they're using, because again, I can then also help at work, and I think Helm is the most popular package manager. But it's good to familiarize ourselves, so at least we have some surface level knowledge. Customize introduces a template-free way to customize application configuration, so it's the same crap, right? Just with a nicer website, pretty much. Okay, cool. All right, I'm not interested in details here, unfortunately, because I'm not going to use it 100%. I've actually used Argo CD sometimes in some company. I don't know where I worked, I believe. Yeah, I think I've used this somewhere. I think this was pretty awesome, actually. Yeah, this was pretty awesome. You have these linear, these are called like linear graphs. Something like Dataform, right, has, where you see like all the jobs in parallel. Yeah, this was pretty cool. I think this is, yeah, but we are like 17 light years away from needing this. Flux. Yeah, I don't care. Okay. I don't care. So Helm, is it going to be? Is it going to be now? Absolutely not. But it's good. It's good. It's good. So all of my suspicions and things are correct. And that feels good because I understand it. I mean, I get it, right? Now it's just a matter of time. Now it's a matter of, having this. I mean, I only do this in the stream, right? So this time we spend here together, that's the time I have to learn this. So, of course, things take time to memorize, and let's not pretend that it's easy. So we're going to take the time. It's going to take some time, and that is fine by me. If it was easy, then, well, great things take time. Great things take time, right? So, okay, the only last question I have is that, so with Helm, so my only irritation right now is that for each of the given files, given resources, a deployment, a service, a PVC, etc., I have to run the kubectl apply. Does Helm solve that somehow? Would I apply changes somehow differently, or to say, would I deploy the entire node, let's say node go API with just a single chart command or whatever? Yeah, deploying and managing Kubernetes resources individually with multiple commands for each can definitely feel cumbersome. This is exactly the type of problem Helm was designed to solve. And yes, you can apply changes to all resources in a single step with Helm. Single command deployment with Helm, you don't need. Kobe, my friend, good evening. Good to see you, man. Thank you for coming. With Helm, you don't need to separately apply each resource. You can package all of your resources into a Helm chart that can be installed, upgraded, and deleted with just a few Helm commands. After packaging everything in Helm chart, Helm manages all resources together as release. You just need to run Helm commands. Okay, I'm not going to do, again, we're not switching to Helm by no means. I just need to seed this, as my PM Stain at work says. I'm just Alex. Don't think about it now, dude. I just want to plant a seed in your head. So right now, I'm just planting the seed in my own head, just so my brain can process this when I'm biking in the gym or whatever. It's wonders happen in your brain when you're not by the computer. Instead of running separate kubectl apply commands and other resources, you bundle them into a Helm chart and manage the entire life cycle of the app with Helm via sync. Yeah, that's amazing. But we will suffer. I will explicitly choose the pain for a few weeks. With Helm, you just need one command, blah, okay. Cool. All right, and then we just have some handlebars, if you may, some templating engine here. Yeah, there it is. We just parse some values from, I guess, the variables. Sure, that's a cool story. Then we have the service. Yeah, whatever, same crap. We're just interpreting values from a different file, PVC. So that pretty much stays identical, which is good. I would fucking hate if a package manager would alter how native YAML configurations would look like. That would make it, I would never use it instantly, I have to tell you. And then the values, I get this. So this is their own way of how they do it. And that I respect. That's okay. This is pretty cool. Yeah, this is pretty. It's just, where is this node? How does this chart file looks like? I haven't seen that. Values, config map, make sense, PVC, service, deployment. Okay, so I guess this is some sort of a file that their package manager generates. Helm install my node app. Okay, so this is the name of the app, I guess, of the deployment or whatever, of something. and then I provide this as an argument. Deploy all necessary resources. I see Helm will also package everything as part of release for easy management. To delete the entire deployment. Yeah. No, this is amazing, and I can see that this is definitely the path we will end up. This is something we're gonna end up using. There's no single question about this, but of course not yet. As I said, we need to learn the basics yet. I mean, I'm getting it day by day more and more, and it's going really well, and I'm happy. But yes, we are still far away from pretending again that. So once I'm able to sit and write, so in a couple of streams. Once I'm able to write all of this end-to-end thing on my own, so it's not that we're super far from that. Once I'm comfortable with that, once we're comfortable with these common commands, where is it? Common Kubernetes commands. Yeah, exactly, core. Yeah, for 100%. I got it. And then, so once we're comfortable with all of these commands, once I can run my K3S thing and kind of make sense of it, right? Then we're gonna be good, because this is what my team today at work, this is what my DevOps guys are using, and this is a super nice tool. Like, it's basically having like a GUI tool just in your terminal. So I want to master this over time. When I say master this, it's not rocket science. I just mean once I'm comfortable, this is going to be my tool for managing resources, because you get pretty much the same shit as you get in the browser using Lens or whatever. Almost, it's just you can run this in your terminal. If you haven't seen this, it's called K3S. I don't actually have the dot files. I used to manage that file somewhere on my GitHub, but no, not now. I mean, it's and mainly because I'm running Windows Linux subsystem, because unfortunately I have to stream from Windows. Why am I streaming from Windows, you might wonder? Because this microphone, this webcam, Razer Kaya Pro Ultra, this 4K, like none of this shit works properly on Linux. So basically I'm using the Windows environment to stream, and then I'm running all of the stuff that you can see in Windows Linux subsystem. Luckily, this is like an insane computer. It has 16 core CPU, RTX 4070 Ti. So it's you can see it's a pretty insane machine. It has DDR5 running on 6000 megahertz. You can see CPU basically is like underutilized because there are 16 cores. So that's why I can also stream from the Windows, is because yeah, it's just makes sense. You collected a PC this week, nice. But okay, this is superb. This is, by the way, for you, Weasel, and Kobe core. So load balancer is running. Metal load balancer is running. So if I show you get SVC, right? So we can see here that now we have a load balancer. It's exposed to. So basically, we also limited my. I limited my DHCP server pool to issue addresses only from a certain range, and the rest of the range is devoted to the load balancer. So you can see what I've did. So this address pool for my default DHCP here was from 10 until 254. So I kind of reduced this subnet to fewer addresses for my local stuff. And now my load balancer is basically getting this IP range. So we did that as well, because basically, if you remember, we discussed it last night, that we're gonna have to give an IP pool to the load balancer and ensure that nothing on my router, for example DHCP, is not assigning the same IPs to some other things on my network. So we made sure of that. So yeah, this is what you do. You create this kind, which is IP address pool. This L2 advertisement is their algorithm, their simple algorithm on how they issue IPs. I'm not going to pretend that I fully understand it. I don't, of course. I will over time, but not yet. So that also now works. And yeah, so basically what that means, right, is that now I can actually go to my actual local address here Here we have the nginx, as you can see, right? And then if we go to a database, you will notice that we are actually connected to the external IP. So you can see here, so it's not node port anymore as it was last night, if you remember. Now we are actually exposed. So now I would do network address translation on my router if I would want basically for you guys to access this as well. But there's a lot more work we're going to have to do from SSL and probably some sort of nginx. I don't know if we're going to need it. We'll see. And then all of the stuff we need to do with Cloudflare, but to automate stuff, right? Do you have any... SSL is easy, don't worry. Unraid. To be honest, I don't know what Unraid is. Let me see. I'm not a... Keep in mind, guys, I'm not a DevOps engineer. I'm a full-stack engineer. But I love... I mean, I've been doing computers my whole life. If this is what you're referring to... Yeah, to be very frank with you, I've never heard about this. I've never heard about this, but I mean, thank you for mentioning it, because now I have heard about it. And let's see, what is this for? Okay, well, let's do the typical stuff first. So let's use AI in an intelligent way. Explain to me what is the selling point and why would I use it? I do, but I have YouTube channel, right? So all of the stuff is on my YouTube. So if you go to Programmer Network here on my channel, and then you go to Live, you have all of the streams here. I just don't do it on Twitch because Twitch sucks in general, and I mean, none of this streaming is pointless in any way other than having fun and meeting people like yourselves, guys, and having to do. But from any financial or any other perspective, it's a massive waste of time, right? So at least I wanted these VODs to be on YouTube so someone else can also see them, right? I mean, core, you should share a bunch of that stuff on Discord with us, man, or on Programmer Network platform if you have signed up. All right, let me just read this because I want to have this reference point. Unraid is an operating system designed primarily for managing and utilizing the storage in a home or small business network, but it also offers much beyond that. It allows users to create a flexible, easy to manage storage solutions on virtual machines. Virtual machines. And easily incorporate Docker containers. Nice. Flexible storage, hybrid arrays. So basically, we're using Longhorn. So what we have set up now, okay. So let me just tell you. So what we're using as part of this Kubernetes cluster is Longhorn. I don't know if you have heard about it, but people in the stream have taught me about it, or they told me that it exists. But Infinite. Good evening, buddy. How you doing? So let me show you what Longhorn is. So a couple of days ago when I started streaming again, I haven't streamed in months. So after I started streaming, basically, as part of this Kubernetes thing, I wanted to do RAID 1, right? So if we switch here to my cluster camera, give me 1 second, where the hell is it? Here, you can see that I have these hard drives plugged in. Let me show you. So what I wanted to do, right, was I wanted to set up the RAID one, right? So I wanted to plug multiple of these drives into a single Raspberry Pi. So let's just illustrate that. So I have 4 Raspberry Pis now, as you can see. So let's imagine I wanted to plug multiple disks into RP2, like this, and then I wanted to put them in a RAID 1 mode, right? So mirroring mode. RAID 1 basically is mirroring, right? And I'm sure you know that, but just in case, it doesn't matter. So I wanted to have something like this, and then I wanted them to run in RAID 1, right? And then so this is RAID 1, basically mirroring, right? So whenever something gets stored in 1, drive, it gets replicated to the other drive, right? And that's still a valid way to do things in many data centers and in different setups and environments, right? But then some of the guys, so okay, let's just discuss this for a second. So, and then as you saw, there's other 3 Raspberry Pis. So let's just put these 3 boxes like this, right? And so, but what is the problem with this setup in the context of Kubernetes, right? Or in the context of any setup? Well, the biggest problem with this is that if this node fails, so if this node goes to shit, it's like farted, and it's not a main one, it's, let's say, a worker node. So this is, let's say, a worker node. Then it doesn't really matter that I have redundancy on these disks. Yes, the data is still there, it's safe. But my database is dead, or any other service that's utilizing the volumes, because this node is dead. So that kind of ruins the high availability premise that Kubernetes promotes, right? So now, instead of that, I said, fuck that, right? Let's not do that, because one of the guys here in the stream is smarter than me, and he said, hey, Alex, have you heard about Longhorn, right? And I'm like, yeah, of course I've heard about Longhorn. I just hear about it all the time. Jokes aside, of course not. I haven't heard about Longhorn, right? So with Longhorn, Longhorn is similar to this RAID type of thing, right? It's not, but it is. Bear with me. So what Longhorn does, Weasel, thank you very much for coming, man. Please come anytime I'm here if you have the time. I appreciate you, man. So with Longhorn, what Longhorn does is similar to RAID 1. It replicates your data to all of the hard drives that are plugged to individual nodes. So let's imagine these are my Raspberry Pis. So again, let's take a look at them again. So you can see each one of them has its own external hard drive. Thank you, man. Thank you very much, dude. So now what Longhorn is going to do when you create a PVC, when you create a when you create some sort of when you provision some space, it's going to replicate data on all of the drives, all of the replicas that you defined, right? So if we take a look at that here, if we take a look at the PVC of something, so Longhorn PVC, you can see here I'm saying I want to create some persistent volume claim, blah, blah, blah. And then I have this storage class where I define on how many drives do I want the data that's stored to be replicated. So whenever something is stored somewhere on some PVC, on some persistent volume claim. So let me actually show you also visually, so bear with me. So you can see if I go to my volumes here and I click on one of the volumes, so you can see that any service that's using this volume, it's replicating data on 3 different hard drives, right? Well, I mean, so not to get into any sort of details, I'm just going to stick to this, right? So right now you can see you can create a storage class, which is let's call it an object that defines how many replicas you want. So you create a class that defines, as you can see with this metadata. So any PVC created off of this class is going to replicate data to 3 hard drives. You can say 4 or how many drives you have. What is it going to do? What is the stale replica timeout? So for example, if one of the hard drives is not replicating data for more than 30 minutes, then you probably want to nuke that and get the stable data, get the latest data, because you always want to keep these hard drives in sync, right? But the point here being is that now this Longhorn thing works almost like, it's not almost, it is mirroring in a way. It just does it over network, right? And it doesn't store it on a single node, it stores it on multiple nodes. So if my Raspberry Pi 3 dies, there's still Raspberry Pi 2 and Raspberry Pi 4 where the data still persists. If my Raspberry, so you get the point, right? So versus the RAID 1 that we saw where, well, you smack the drives into a single node and then, yeah, that's great, but what if that node dies, right? So that's what we're using Longhorn for, right? For that sort of redundancy. So that's why instead of going RAID 1, some of the guys said, hey, have you seen Longhorn, right? And that's what, and as you can see here, and all of this stuff is gonna be on GitHub. I didn't push for, as you can see, I have 12 files that I haven't pushed yet, but you can actually see most of these things if you click on that repository that I've shared in the top for you guys. this one here, right? You can find all of these things. You can see this is unfinished guide. But you can see if you go here to exercises and you go to Longhorn, you'll see very basic stuff here. So that you always create a storage class, right? Which is a kind, which, yeah. And then you define some parameters here, like things like PVCs created off of this class should have these claims, these rules and stuff. Then you create you provision the persistent volume claim. And what is the volume? Well, it's you can pretty much visualize it here. It's a way it's a way for you in a way to also not think about physical drives. You're just saying, hey, I want to allocate this much space of this kind, of this permission, read, write, whatever, of this, that, and that, and then I want to be able to use that with this application, this deployment, right? So that's why when you go, for example, then to we can also go to that repository. So if you then go back here, you can see we have an Nginx pod, and here in the pod we're saying, okay, hey, and I want to bound some volume. I want to allow this Nginx to have some data storage, and here it is, right? Volumes, name, data, persistent volume claim. What is the claim name? Well, Longhorn PVC, and if we go back, we'll see that that's how we named this one. So you could, if you name this one banana, obviously then in the pod here you would bind it to banana, and then you would go to your Longhorn GUI thing, and then you would find that specific thing in here, right? Exactly. It's just so you can see that you don't really need a whole operating system. My point is to get this functionality, right? All right. What is the time? It's 11 o'clock, guys. I need to go. It's I didn't even plan to stream this much, but it was fun. So let's round up. What can I say? Core, thank you very much for being here, man. I'm sorry that I have to go, but I worked the whole day. I had my Danish school. I've been with my wife and kid, and I have to go to work pretty early tomorrow. Then I have a gym. I have a lot of stuff. So let me just cut it here instead of just prolonging and getting. It's 11 p.m. here. So core count. Okay. Oh, core count. Okay. It makes total sense. Sorry, but you should probably tell me your real name. But yeah, well, thank you very much, man, for the compliment. We are learning this together. So let's, we just stay humble and we just learn things and we enjoy it. There's nothing, Phil. Well, you know, I'm Alex, so good to meet you, Phil. Let's just learn together, man. And these are amazing things. These are super fun things. These are good things to have for the career, even if you don't fully embrace, fully learn it. It's still nice to at least have an idea of how these things work. So there's nothing more than I enjoy, you know. At my work, as some of you know, I work as a tech lead. So sometimes I can feel that maybe I'm not longer learning as much as I would in some domain. I'm learning a lot more about leading teams and leading people and being better at articulating ideas. And I'm learning so many things, but sometimes I lack more of the, you know, technicalities because, you know, I spend a lot of time with people and helping others. So this sort of stuff is super impressive and super fun. So we're going to be doing this for a couple of streams, or maybe, who knows, we're going to be doing this as long as we want and as it's fun and we learn. And then, yeah, we'll see. And then we'll, of course, go back building programming network, moving the infrastructure here. So there's gonna be awesome things that we're going to do, and it's going to go really, really end to end, from touching various types of things, all the way from some hardware to you know, to building UIs and APIs and schemas and tables and joins and aggregates and you know, you name it. So because it's fun and it's like, shit, how does this work? I need to know how this works, right? Okay. Phil and everybody else, thank you very much. Thank you for your follows. Thank you for your help. I very much appreciate it. Thank you for teaching me some of these things. And I'll see you guys tomorrow in the evening. Until then, I wish you a good night or day, wherever you are. And I'll see you guys tomorrow. Okay. Peace out, everybody.